let's see. Okay, so I need to create a function to rotate it along each axis. Okay, so rotate X. Then we have the just beacons, I guess. And so I saw somebody, it was like this, nice and flipping people off, right? So rotating along X, and the Y, the Z, the Z becomes Y. Like, if it's Z becomes Y, Y becomes negative Z. And then negative Z becomes negative Y. And negative Y becomes Z. It's positive, or well, actually, because I need to look at because the right side just depends on how I'm looking at it, right? So, got X, Y, Z, and then if we go like this, we rotate. It depends on how I decide to rotate it, though. I just need to make sure that I do it consistently. So yeah, it's okay. So X stays the same. New Z. New Z. New Z is now, this would be negative Y. There's only 3 numbers. If it's negative, it becomes negative Z will become negative Y. Positive Z will be positive Y. So that's only if what do you call it? Let's see if I rotate the numbers, I keep the X the same. So Y needs to be turned into a negative, or inversed. That's the same thing in terms of numbers. So it would be negative y. Or, well, we'll figure that out later. Then the new y is negative. No, let's see. Z, new y. Would be the previous z. I think those are the only things that change. So they become negative, or inversed. Yeah, we can try it. Well, okay, so x, y, z equals beacon. Let's see. Let's see. The beacon. All the beacons need to change. Based on the result. So bundle up. I need to save the Then all I just need to do is just copy these. Okay, so rotate Y, rotate Z. Okay. Let's change these. Okay, so for Y, how do we rotate? Rotate around. Doesn't matter. We just need to be consistent, which it is, because there's only we do clockwise this way, or counterclockwise. So X becomes Z. So Z equals X. And then X equals negative Z. Then we do Z. Let's see. X equals Y. Y equals negative X. Okay, rotate X. Y and Z. Okay, so we're splitting by new lines. And then Or, well, not new lines. 2 new lines. Okay, here. And then this doesn't really matter. So there are 24 different positions or orientations that the scanners can be in. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then each of them being considered up. So you double that because of the okay. Because then you can also rotate this way. Okay. Okay, so what to do next? By finding pairs of scanners that both see at least 12 of the same beacons, you can assemble the entire map. Scanner 0 and 1 have overlapping detection cubes because it can only detect beacons within 1,000 units in each direction. So it's 2,000 by 2,000 by 2,000, right? So if I move in one direction,
Why is
then only one axis changes. So let's see. What I'm thinking of doing is I can line up the X value of one of the scanners. Like I can lower all the X values by 1. Let's see. Because it's relative to each scanner. I've got 2 scanners in 3D space. Don't know their orientation. Let's say 2,000 for each of them. To see how brute force would, how long it would take or whatever. 2,000 in each direction. Not quiet, but this is the worst case scenario or whatever. 2,000 times 2,000 times 2,000. Is it, let's see, is each okay, so let's see. The scanners and beacons map a single contiguous 3D region. This region could be reconstructed by finding pairs of scanners that have overlapping detection regions, such that there are at least 12 beacons that both scanners detect within the overlap. By establishing 12 common beacons, we can precisely determine where the scanners are relative to each other, allowing to reconstruct beacons. I don't need to check each and every individual what do you call it? Every cell or whatever. All I needed to do is match one of the beacons, or like, so I start by, randomly or whatever, selecting a beacon from one scanner to a beacon of another. And then what I do is I change the axis, or the what do you call it, the X, Y, and Z coordinates of every beacon within the second scanner's list. And then I just see if any of the other ones match. If they don't, I rotate it. Would it be of any benefit to zero out any of the beacons and then check from there? Let's say if I sort the beacons, because that doesn't matter. Sort the beacons. Yeah, I don't need to worry about zeroing out anything. But I do need to match the beacons as I check them, because that's, or actually, I mean, yes, map them, but instead of changing all the values and making another list or whatever, I can get the change in the X, Y, and Z coordinates, positions or whatever, and then just do the mathematic comparisons and operations and check. Because it doesn't matter where This is a difficult one. I'm going to make a function that will run the individual scanner matching, check for match. That's a great idea. Should I do camel case or should I do snake case? Check for match, S1 and S2. So let's see. So we got the change. So what we do now is let's see. I want to, so this is testing for each scanner within scanner 1. So this should actually be beacon, not a scanner. So for beacon, yeah, that's true. Okay. Yeah, so beacon. There. What? Interesting. I'm gonna have to change that. I guess just do something with Vim. Oh well. It's fine. Practice, practice, practice. Bacon. So we've got a base. This base scanner should actually be base beacon. Oh, cool. So I should have named all of this. Oh well, we're good. That's okay. Okay, so we've got the change, and so then we're going to do temporary beacon placements. Temporary beacon placements, TBP. And this will equal a TSD spoons. Temporary scanner 2 beacon placement. Yeah. Okay, so then what I do is I will go through the beacons. So for beacon in scanner 2, 1, I will do TS2BP dot append, and we're going to append. This is going to be the beacon minus the exchange. Let's think for a second, because the base beacon minus beacon, so that's the difference between. So beacon minus the exchange should get us the base beacon. Beacon 0, because we're looking at scanner. The first one's scanner 1. For beacon in scanner 1. Okay, so we'll just have to go back to it if it doesn't work. So, append exchange, or B0 minus exchange, B1 minus Y change, and B2 minus X or Z change. So then we have our temporary scanner 2 beacon placements. And what we're going to do is I want to go through each scanner, or I mean each beacon. So I think I want to indent this. So I'll get rid of that line and then unindent these guys, which I don't know how to do. That's fine. Do it the old-fashioned way. So instead of the beacon, this needs to be scanner 1, 1, 1. Wow. So we'll copy that, and then we will just sorry about that. Okay. So now we are going to do, we're going to check to see if there are other beacons, because what we're doing right now is we're offsetting by a vector or whatever each of the axes. So I'm not rotating, I'm not mirroring or anything like that. All I'm doing is just up, down, left, right, forward, back. So everything is staying in its same position relative to the scanner's face. Because I don't care exactly right now, at least, what the position of the scanner is. I just want to see which beacons match up. So for beacon in TS2P, I'm doing a while true because I know I'm going to be breaking out. So we're going to go through and what do you call it? And then else or whatever. We're going to break out of the while loop. But for this, cool. For beacon, okay. What we're gonna do is within this while loop, we're gonna have a total. It's going to be 0. If beacon is in scanner 1, 1, then total plus equals 1, and I could make them tuples, because then we can search in terms of 1 versus, you know, the length of the array, which is 25. So we will okay, so for else, if total is greater than or equal to 12, then we are going to return true. Just for now. Otherwise, what we're going to do is go through each of the options. So instead of this, we'll do option is less than the length of options. So this is options is going to be a list of the different functions that we're going to run on them. That means we will need to then redo this. So I need to move these down to within this and tap those in. That means these lines additionally have to be moved in. We'll just have the position be 0, and then so we'll check if the position of, or the position is less than the length of. Okay, so what do we see now? Okay, so we've got our scanner. Because as soon as I rotate one of the axes, I have to then redo the X, Y, and Z change. Base beacon is also going to be different. Silly me. The options need to be because I need to rotate at around X 3 times. So there's 4 in here, 4 in here, and then 4 in here. So it's like, so it's 1, 2, 3, 4, and then I'll rotate this, and then do 1, 2, 3, 4, and then rotate it again, 1, 2, 3, 4. I rotate it again. I just need to flip all the things. I don't know how to check all the different orientations. Plus, what I'm doing, it checks one of the scanners from scanner 1, and then compares it against all the scanners from scanner 2. So, need to change it up a little bit. What I'm doing is, because if that specific scanner is not in the group, then it doesn't matter, because none of these other ones are going to be lined up, or be, they're way less likely to be lined up. So I then have to redo the base beacon against every single scanner. So what I wanted to do is I'd rotate X, rotate Y, rotate Z, I think. So it'd have to be a function call. So I'd do XC rotate. The beacons. Well, obviously, but then it's going to need the functions that are going to be called on it, and then I'd return functions, 0 or whatever that would be called on. If that even works. I could functions 0, functions 1, functions 2. 1, 2, 3. Because I don't want to. Well, actually, let's look at the check it for match. The base beacon. So, yeah, the base beacon is fine. We don't need to have these in the while loop. We don't need to reset those. But creating the temporary displacement list. But it's based on the displacement list, the next time it runs, right? Base beacon will need to change. So that each time base beacon so this one I can set outside, but then at the end of a thing or whatever, I would need to, still within the while loop, I need to restate base beacon as being the rotation of or the new rotation. So I want to make sure that these are, the beacons are tuple, so it searches through them a lot quicker. They can be turned into a set. So the beacons will actually be a set because they cannot have the same, they cannot occupy the same space. So this will be a set. And then, cool, so then we're checking, they cannot be indexed. And so, if you're doing that, let's see if I check if beacons in scanner 1. Yeah, I'll have to refactor that later to see if it works. So we have the exchange, base beacon scanner, for being scanner 2. So the total is what we are checking after we rotate the space. So that resets every time we rotate. So I'll need to then rotate the two scanners. I don't want to actually change the scanner to locations that are relative to the scanner. And I can do this a different way. So then the base beacon will equal I'll just have to make a copy. Okay. I forget. I don't have a list. It's not gonna work anyways because guys, I'm still good. Let's look at my inputs. We'll just look at there. So it doesn't run through it anyways, so I guess beacons.scanner to .copy has the, I mean, I can always change it. Okay, so we've got the beacons, and then, so instead of that, it's going to be the beacons. One, so we're checking once. 1, 2, 3. And then we're going to rotate it again. Because if we're looking at a Rubik's cube, it has 6 faces. Each of those faces could be rotated in 4 different ways. Okay. So what I need to do is I'll have a face. So whatever direction it was facing to. And then I will rotate it around that face 4 times. Or, well, 3 times. And then after it's made it around again, so after it's upright, I then pick another face. There are 6 faces, 4 options each. That's where 24 comes in. So for, let's just, for face in faces, we're going to do where we can make sure like it's oriented in a specific way. And then what we do is for rotation, for R in rotations, then we rotate it in a specific way based on its face. Okay. So we rotate. So we don't have to worry about keeping track of faces. We need to keep track of how we input the rotation list or whatever. So if we're on a face, like this, and if we decide to rotate it around the face, the bunch, then as soon as we rotate it in a different direction, that face will no longer be the face. And so then we rotate it, 4 times or whatever. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we have to do it on the opposite sides. I could do a function list. Oh, sorry. So function list. This is what I was. So I don't have to put the name function list. But what I would do is I'd have a list of lists or tuples or whatever. Of the different rotations I would need to get to each side, and I could just rotate around, X or whatever at the end of each rotation, and then that would be the same. So if we look at X here, we want to start X. At the end of it, we want to move it. Same with the basic rotations. So we could have, rotate Y and rotate Z, the functions themselves, and then we just, copy the list or whatever, because this wants to be done. Oops. we're going to be doing it 3 times. Actually, 6 times total. So we're starting in the front, and then we're going to move this up 1, and so it'll just be Z or whatever. So rotate Z, and that'll be so rotate Z, rotate Z, rotate Z, rotate Z. So just 4 of these. And then, to get the last 2 faces, 1, 2, 3, 4, we're going to do rotate Y, and then rotate Y twice. I think that's will work. Okay, so this is after the fact. So after we do the 4 rotations within on this face, we rotate along the Z. So 1, 2, 3, 4, done. 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 So the 4th one is going to be rotate Z, rotate Y. And the 5th one's rotate Y, rotate Y. Okay, and then we'll just put another, rotate X, because we're not going to use it for our So now all we do is rotate X. Four times. You don't need to put it in there, still. Range 4. At the end of the for loop, we new beacon placements equal rotation of previous beacon placements. So, and then that's the same for same as above, just with different rotations. So we need to check here. Our axis rotate, so beacons, and then functions. Position equals 0, while, actually false. For func and functions, beacons equals func beacons. There we go. And then what we would do is we just return beacons. Okay, so it'll be, here. Okay, I'm feeling good about this, even though it's completely random and slow and probably wrong. Ha! I love it. Okay, so in this case, we're going to pass. We need to make sure to pass a list. So each of these can be. Each of these are going to be, well, yeah, in a list. Even these guys, I know. Because when I pass it to this axis rotate function, the functions are expected to be an iterable. And if I pass in just a function, then it's going to give me an error. Unless I were to like make my own weird subclass. I don't want to do that, right? Okay. So we have our. Okay, this displacement list is initially not going to be, or is initially going to be created, but afterwards it's not going to be, I don't need to I don't want to remake it, I think. Because the base beacon will be, okay, so base beacon needs to be what the I think I need to this beacon's one. Needs to be the same. beacons 1. So this is where, okay, so then beacons is the copy. Okay, so right here is where I need to do the adjustments and rotations for each one. Okay, so then beacons equals rotate X, beacons, and then between the for loops I will make beacons equal axis rotate beacons and function list. Okay, so I want to print the total. Index out of range, base beacon minus. Index out of range. Z change equals base beacon because this needs to be base beacon 1, base beacon 2. Silly me. Okay. Int object is not subscriptable. Check this for match, and then TS for B and beacons 1. Where did I have beacons before? I just want these to be beacons. So That was only checking... No, that was checking all scanners against one specific scanner on scanner 0. Or, well, the first scanner within each scanner. What I want it to do is compare it against each and every scanner, I think. So what I could do is I can match it up against... I can match each scanner against each of these scanners. So it's going to be 25 times 25. But then we're, yeah. It's going to be 25 to the 4th power, I think. At least. More than that, actually, because for each rotation phase. Check for match. So now, S1 number beacon green. S2 beacon. Beacons copy cool for. So if I do it this way, I actually don't have to check the different permutations or combinations. So I will check scanner 1 against scanner 2, 3, and 4, but I don't have to check scanner 2 with scanner 1. I'll fix that later. Okay. Base beacon equals this is actually going to be beacons S1 beacon. And then or actually S2 beacon. And then the scanner 1. This one's gonna be S2. Or no, let's see, S beacon. greater than 1, we're going to print it. Let's see where they're print. Oh, that's if they match, which is actually exactly what we want. So like I was saying with this, I'll go through the scanners. If scanner 1 if scanner 1 0, let's do this if scanner 2 0, oops, is less than or equal to scanner S1 0, then we'll continue, because we don't need to check 1 against 1, 2 against 2, 3 against 3, 4 against 4, or yeah, we only need to check each combination once versus flipping them. So kill terminal or clear terminal would. So if there's a match, I don't need to go through the let's see. If what's it called? I want to break out of the loop so it doesn't keep redoing it over and over if it wants a match. Loop beacons, I don't know. S1, S2. Then we will continue. And then, so I put all of these into a function called loop beacons. S1 and S2. And then there's this. Leave this, okay, S2B. Let's check match was 1 for match. And then I'll print what they, let's see. Return true. Let's pretty print it. Or for now, let's just do the number. So in this case, it's finding 1. Let me re-put in the scanners and beacons map a single contiguous 3D region. This region can be reconstructed by finding pairs of scanners that have overlapping detection regions, such that there are at least 12 beacons that both scanners detect within the overlap. By establishing 12 common beacons, you can precisely determine where the scanners are relative to each other. Because all coordinates are relative, in this example, all absolute positions are instructed 0. Using the orientation of scanner 0, and as if scanner 0 is at coordinates 0, 0, 0. Scanners 0 and 1 have overlapping detection cubes. The 12 beacons they both detect are at the following coordinate. These same 12 beacons in the same order, but the scanner 1, okay. Because of this, scanner 1 must be at this coordinate relative to scanner 0. Scanner 4 overlaps with scanner 1. So I go through, I select the beacons in which because the base beacon needs to be no, I select beacon 2. This needs to be I don't need to do that actually. Zero and 1, 1 and 3, 1 and 4, 2 and 4. Which ones line up? Zero and 1, 4 and 1. Okay, I mean, so 0, 1, 2, 3, 4. We have all the beacons, right? Because it goes to 4 beacons. Well, yeah, 5, but yeah. So we're able to match all the beacons within relatively small amount of time, considering we're checking every single beacon against every single beacon. Oh boy. Okay, so when we find a match, I think we should do so this is the rotation, the face function list, and then rotation. So what we're going to do is we're going to create a what do you call it? A list. My hotkey is deciding not to work anymore. Okay, whatever. Okay, so yes, I'm going to create a list. This is going to be completed functions, rotations. Let's create a list. And then when I complete a rotation, I'm going to have that be, so after beacons is rotate, I'll do complete rotations dot appends x. I can do the rotations. That's fine. I can add the rotations themselves. So I'll rotate X. And then after this, completed rotations dot extends function list. Okay, so then I'm going to return completed function rotations So then when I'm looping through, excuse me, check match. Okay, because this is checking for the match. Okay, so if it returns, so it's returning a list that has something in it. Therefore, it is good. So, I know which scanner it is and the rotations. So instead of this, so the completed functions, so CF equals check for match. And then if CF, I'll do these things. I'll print the I'll go ahead and print the those and then the completed functions. And then I'll return true, just so I don't go through it again, right? Nice. So this is so is one compared to, so it's the second scanner. I'm rotating the second scanner's beacons. Okay, so these are the list of the functions that put the length of the functions that I do. So, whoa, wait, what's going on here? It's an empty list. So I can just return. As instance, if his instance, CF, and we're checking if it's a list, then we're going to print it. So the orientation of scanners 1 and 3 are the same. 0 and 1, I have to do 12 total rotations. 1 and 4 is 8, 2 and 4, there's 7. I have to rotate 4, so 7 times. Okay, so I find the orientation that needs to be in. what I need to do is find where in 3D space that second scanner is compared to the first one. So if we're looking at 0 and 1, but rotate it 12 different ways, I'll find the match. What I do is all I do is just subtract the that list. So match will equal loop beacons. Oops. If the match, then I can do or just scanner orientations, it's fine. We'll append let's see. For now, I'll just append match. Just a list, whatever. In this case, I will pretty print them. So I'm returning. So I'm returning true. I want to return S1, 0, S2, 0, and CF. Let's see how that does. Okay, good, good. Very, very nice. Okay, awesome. So I've got the first scanner, second scanner, and then orientation. Or, rotation. So this one rotated X 4 times. So technically, I can remove all those rotate axes. If R yeah, if we go through all the way. Then completed rotations. Excuse me.
Not now, later. No, now. Why did you leave her? I don't want to talk about it. I do. Can't you let me hold on to some pride?
Then completed rotations equals completed rotations for a non.
What girl?
Because oops.
Her name was Alicia. Who's she?
So let's see if that works.
I don't know. He was very insistent.
X, Z,
Alicia.
X, X. Oops, I can just go up. Okay, let's look at this last one. It rotates, or it checks all those spaces, and then it does a Z and rotates twice. So instead of rotating all those 4, we just do Z and rotate twice. So when we look at this one where it does X, 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 and then Z or Z, X, 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 and then Z, X, X. So instead of rotating it not 4 on, it needs to be negative 4 on, right? No. Let's see. afterwards I go through. Oh my goodness. So, I don't want to return a function. I want to argue. So I think that should work. So z, x, x. Instead of xx, xx, z, xx, z, xx. So there's two z's and two x's at the end. Two z's, two x's. One z, three x's, one z, two x's. So I'm minimizing the number of rotations I have to do in the future. Okay. Another thing I need to do is return which beacon I tried it against to match them up. Sorry, excuse me. So what I'm going to do here is so the scanner, both scanners, then I need S1B, S2B, and then the function list. So then I know that let's see. So scanner 0 and 1 are, they match up using, so scanner 1, its beacons, I will need to rotate the z-axis, rotate z-axis, and then x-axis twice. And then I compare those, all the beacons, I will subtract the difference using beacon 3 or beacon 0 of the scanner 0 and beacon 3 of scanner 1. So another helper function, haha. And so what I do is orient scanner Now if I look at this again, so 0 and 1, that's good because it's relative to scanner 0. If I look at further ones, 1 and 3. I have 0 and 1. That's good. 1 and 3. What I should probably do is, once I caught after I find the whatchamacallit, if there's a match, what I do is I go into the scanners, and I update the orientation and locations of the scanners. So we're 1, 1, 3, 1, 4, 2, 4. So to go backwards, I have to do each of the actions 3 times. So if, in this case, 2 is not in the list at the end when it finds it. Okay, so 0 and 1, they're not on the list, but we start with, scanner 0. Scanner 0 is always going to be the first one, so it's relative to scanner 0. So 0's in the list, so we'll just perform the operations on scanner 1 beacons and, find their relative positions. Well, technically absolute positions at this point, relative to 0. And then we have 0 and 1 in the list. So then, when this goes through, this next one, 1 and 3, 1 is in the list, so I need to do one of 2 things. One of these options. I need to either apply the functions that were part of the allowing that second scanner to meet 0 and add it to, the 1, or I need to just orient it after it's added, or before it's added, technically. So 0, 1, okay, now 0 and 1 are in the list, and so I look at 1 and 3, okay, compared to 1 and 3, let's just say this is the updated one, there's nothing to change, cool, so 3 is added, don't need to change anything. 1 and 4, okay, so before I put 4 in the list, I'm going to perform these actions to 4, put 4 in the list, and update its scanners, beacon's orientation. And then, when 2 is compared to 4, this will be different. This will not show. I think I like that idea of updating the scanners. Okay, so if I do a second option where I change the original scanner's items. Then I'll need to update this for loop just a tiny bit. So for scanner in range, no, because it's dictionaries don't have a length, do they? We'll find out. Okay. It's not too big of a deal, but something I should have looked at before. I have scanner and scanner twice, so it's scanners. Let's cool. Okay, Intel just not subscriptable. Equals scanners 0. Okay. But this actually needs to be, it's going to be tuple of scanner and scanners scanner. Okay. And that's going to be the same for this one down here. Oh my goodness. Okay, cool. So then let's change this into Wagner. Scanner. Let's see how it looks. It appears that it's about the same. 1.38, 1.37, cool. So now, instead of looping the I'm sure it creates a list anyways, but so this way I can update the original scanner list. So then scanners will become so if there's a match, scanners equals, we don't have to worry about too much. Yeah, whatever. Equals orient scanner match. I don't need scanner orientations. Okay. So many scanners. Oh, then I also need to pass in the scanners. Okay. So if match actually probably shouldn't matter. 1314. Because 0 will always be in there, and then 1 will always be in there. And then 1 should match with something, and so then that number should be in there. So this is the match. It's the scanner, first scanner, second scanner, the position that it's at, and then the position of the second scanner's beacon. And then the functions that it applied. Let's see. Beacons equals scanners match 1. Okay. Excuse me. And then what I do is I apply the what I did before is so I rotate and then do the change. So then I do the for func in match -1. Beacons. For beacon in range length beacons. Beacons at that beacon position equal function. Wait. Oh, I just need to rotate it. So okay. For function match -1 beacons equals func beacons. I didn't say, I said func. Okay. And then I do the offset. So let's do another helper function real quick. Offset. Beacons. Let's see. Offset and then beacons, yeah. Beacons. Beacons. Beacon. have to do a little bit different. Okay. Because I don't know the offset. Okay, so I've performed the rotations, so now they're matching, so I just need to pass in so I can get an offset. Let's just do that. Let's get offset, and then we'll do the offset in a different function. So the offset, I need the beacon 1 and beacon 2. And so x equals this is relative. Let's see. Base beacon is the beacon, second beacon. And so I will use the second minus the first. Beacon 2 is 0 minus beacon 1, 0. Equals. So I just need to copy this. Or duplicate. How do I, is it shift alt down? Yep. 1 and 2. Z. Oops. And 1. 1 and 2. And then I return X, Y, Z. Tuples, good. Okay, so then I will do OS equals get offset of scanners match 0 match 2 and that will be scanners match 1 match 3. Okay. Okay, this will be a little bit better. So look at my scanners. So instead of match 0, this will just be B1 and then B2. Scanners S1 B1. So S1 B1 and then scanners S2 B2, and then this will be just in funks. And then this is also just S1. Okay, and then OS is offset. then I will beacons equal offset beacons, and then I'll return beacons. Okay. X, Y, Z, and then beacons. They're just lists, right? They're not, let's see. Tuples. We'll make them a tuple. Okay. Not type objects, not subscriptable. S2 equals scanner, scanner, scanner. Scanners equal orient scanner by its match. I don't want to return beacons. I want to return scanners. S2 equals beacons. And then I want to return scanners. Range length S1 197. a set. It's a set of the so for scanner and scanners. Oh man. Scanners. Dot. Values. Beacons. Dot. Intersection, symmetric difference, update, union. Set scanner. Boom. We'll print beacons. No. Oops. Okay, so our scanners are good still. And they've been updated to positions relative to where they are, right? Let's preprint, see what's in it. Okay, we've got 4, 3, 2, 1, and 0. Okay, good. Alright, let's try that. Or just see what it looks like. Okay, and then we see we have a set here. Okay, it needs to be or. So let's go back. It's not gonna be union, I guess. Intersection. Okay, I think this, yeah. Okay, we'll pre-print that. Okay. -3,000. Yeah. Beacons has a link, right? I mean, set has a link. 1 127. So I haven't done. So this list of numbers, the beacons, should, well, mine should be the same as it. I thought this would be good enough. The scanners would change their positions, but that's not a problem. Okay, so 0 and 1. Good. Okay, we change this one, this one. First directed by that. Okay, it's good. Then we look at 1 and 3. 1 is in there. Okay, 1 and 4. Okay, 1's in there, so that should be fine. This one, 2 and 4. So I'm looking at 2. And we're performing these rotations. Okay, so beacons equals scanners plus 2. Oh, that means 4 is changed as well. Alright. So 4 changes to where it meets. Oh wait, no, wait, let's see. Orient scanner. That means it's going to change 4. Okay. That means I need a known. Set, and then I send it. So so I'll send it into Orient Scanner. Okay, so whatever. Okay. Check functions. Class or tuple type removed. Check function. Then both should be added. S1 and add S2. Dang it, let me turn it. Erg. Let's see if this has 3110. 846 3110 424. Then it's Z, 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 X, X, X. Not forward, it's gonna go backwards. So in funks. Got rid of one beacon. What? Swap funks. For funk in funks, going backwards. No, oops. That's what we want. Yeah, still 127. So instead of ZZX, it's XXX, ZZZ, ZZZ. Because to get to 2 from 4, I have to rotate Z, then rotate X or whatever. So to get from 4 to 2, we have to inverse rotate X. So we rotate X 3 times. So 1, 2, 3. Right. And then do the same thing for each of the others. Do this twice. Or in this case, 6 times. 79 beacons. clearly I have a list of 127, but okay. I'll try to believe you. Let's see. Scanners, KSO, orient scanner, then continue. I have a beacon set, scanners at values, beacons at update set, scanner. When clearly there's matching, because the total is above 12. Well, 12 or more, but completed rotations, dot extend, rotations in this case would be X. S1 is not in KSO, so in this case would be 2. That's not. Let me go through and swap them. And so then the beacons. Yeah, I'm not sure. Because it should be all relative to scanner 0, right? definitely taking a lot longer than sample would. I didn't think it would take that much longer. I thought it would take, what, 5? I guess it goes through each one. If there's a match, I don't want to continue, I want to break. That might be causing some problems. Because I don't need to. No, I need to just continue. Drastically reduces the time because I don't have to. Then I continue on. It's fine. That's probably where a lot of time. Yeah. Never mind. All right, I wanted to quickly update the rest of day 19. I got both parts done, luckily. So what I'd done to do part 1, my answer is 306 for my input. I don't know what was going on before. I had a few extra functions where I checked the offset and changed it and stuff like that. So I just removed those, and what I did is I just set, when I check for it, if it's a match, what I do is I'm returning the new list, and I just apply that new list to be the scanner's updated positions, because all the beacons and scanners, all the beacons are relative to scanner 0. So I just update the second scanner, whatever it is that's being compared against. If it has 12 or more matched beacons, then it just gets replaced with that new list. And I don't think there's anything else that I changed majorly. Oh yeah, I did. What I did is I made a while loop, and while I didn't have all of the scanners and beacons matched together, what I did is I go through the scanners, whatever. Because of the way I have it set up, and I didn't want to have to do like inverse type stuff, I just loop through multiple times. It's slower, but I don't have to write as much code. A little bit more brute force. So what I do is I go through the scanners one by one. If the first scanner I'm looking at is not in my KSO, that's a known scanner, my known scanners, then what I do is I pass over it, so I don't have to worry about, just because of the way my code is put together. But if it is already found or in the known scanners, then what I do is I go to another scanner, and I then check to make sure it's not the same scanner. And then if they're both in the scanning, then the known scan, we don't need to look at them again, so we just continue. And then I check for matching. If there's a match, then I replace the scanner. And so ran through, and I got 306, which is the correct answer for me. And then for part 2, we're finding the Manhattan distance. So we're not finding the direct shortest distance between, or the direct distance between the furthest beacons, but the Manhattan. So you have to do the x plus y plus z directions, and then so what I do is, because the beacons are all relative to each of their scanners, but then when you match them up, the way I have it is I apply and change the relative positions of that second scanner. So technically the scanner 2 is, or the scanning number isn't, it's then therefore relative to scanner 1, or the first, scanner 0, excuse me. And so what I do is, in that same one where I return the list of the new beacon placements, I return the offset of that beacon, because that is where the beacon is compared to scanner 0. And so I just and the X, Y, and Z I don't think they matter. at least it didn't matter in terms of how I ran it because I got the right answer. But yeah, so I add the offset and consider that a beacon, and then add that to my relative scanner locations. And then after that's run, I just go through each of the scanners, and the largest distance equals the max of the largest distance versus the distance between the two scanners I'm checking. And so I got 9,764, which is the puzzle answer over here. So I got that right, and I got 2 stars for day 19. Yay! I'm glad I got through it, because when I originally looked at it, I was I was pretty scared. I thought that I wasn't gonna have the courage to do it, but it's probably just because I was sick and have been sick. But I was feeling better past day, and so I worked on it and was able to do it. So that's good. It takes about 40 seconds the way I have it. I tried to do it better. Originally it took like 70 seconds. Or actually, originally it took about 5 minutes. But then I restructured the way I looped through, and it took about a minute. And then I restructured it a little bit more, and then also made this a set, and then just returned that. So I'm not looking through a list, I'm looking through a set, which is way faster. It's a time complexity of a constant time complexity, and so it was way faster, and I bumped it down by about 40. 40%. And so yeah, that's my code. Sorry, scrolling real slow. You can check my GitHub if you want to look at it. But yeah, there you go. Thanks for watching.